Welcome to the third lesson in session 4 on imaginary and complex numbers. When working with real numbers, taking the square root of a negative number is not possible. And previously we've always understood that the square root of a negative number was undefined. Now to make this possible to work with such numbers, we define the set of imaginary numbers. The variable I is used to indicate imaginary numbers, and the square root of -1 is now defined using the letter I. So we have a few examples. Radicals with negative numbers need to be simplified as any other radicals and expressed as imaginary numbers. So our first example, the square root of -9, gets broken down as the square root of -1 times the square root of 9, and we simplify each radical individually, and that gives us 3i. Just like the square root of -25, we break down, we pull out the negative number, pull out the -1, and that gives us the square root of -1 times the square root of 25, which simplifies to 5i. Lastly, we have the square root of -32. So we take out the negative, and then 32 needs to be broken down by the largest perfect square factor. So we have the square root of -1. 16 is the largest perfect square factor in 32. So we have the square root of 16, and then the number we're left with divided out, 16 gives us 2. So we have the square root of -1 times the square root of 16 times the square root of 2, which simplifies to 4i root 2. Now when adding and subtracting imaginary numbers, we first have to simplify the radical, then combine like terms. Now to combine like terms with radicals, they have to have the exact same index and the exact same radicand. So for our first example, we have the square root of -25 plus the square root of -9. We simplify those down and we get 5i plus 3i. Those are common terms just like with using any other variable, so 5i plus 3i is equal to 8i. In our next example, we have the square root of -4 plus the square root of -8. So the square root of 4 simplifies to 2i, and the square root of 8 simplifies to 2i root 2. And we can't simplify the square root of 2 any further. Those are not like terms. We cannot combine those any further. So we're left with 2i plus 2i root 2. Now we move on to multiplying imaginary numbers. And we previously defined the square root of -1 as being equal to I. Well, if that's true, it would follow necessarily that I to the second power would be equal to -1. So let's see how this works in practice. 4i being multiplied by 4i. Remember, the I is treated just as any other variable, so when they get multiplied by each other, we add the exponents, and that gives us 16i to the second. However, based on our definition, I to the second is equal to -1, and 16 times -1 is -16. So in our next example, we have the square root of -8 times the square root of -27. Now, we need to simplify first. We always want to take the i's out first. Then you can multiply or you can simplify. For this example, I would recommend we're going to simplify each radical first. So you have the square root of -8, which simplifies to 2i root 2, and the square root of -27, which simplifies to 3i root 3. Now we're in a position where we can multiply each individual factor of the problem. So 2 times 3 gives us 6, I times I is I to the second, and the square root of 2 times the square root of 3 is equal to 6 as well. I to the second is equal to -1, so we're left with an answer of -6 root 6. Finally, we move on to complex numbers. When working with real numbers and imaginary numbers together, the result is called a complex number. Complex numbers are always written in the form a plus bi, where a represents the real part of the number and b represents the imaginary part of the number. Adding and subtracting of complex numbers, we always look to combine like terms. So we combine the real part and the imaginary part. And remember, appropriate form for complex numbers is to list the real number first and the complex number second. So 2 examples, we've got 3 plus 2i plus 4 plus 8i. Combining the 3 and the 4 gives us 7, and 2i plus 8i is 10i. When subtracting complex numbers, we have to distribute the negative just as we did when we subtracted polynomials. So that gives us 10 minus 6, which gives us 4, and 4i minus 3i gives us 1i. And that wraps up this lesson, so good luck on the quiz. Email us if you have any questions.